Hello students, today I am going to explain about the term power of lens in physics for class 10. Now the power of lens is defined as the ability to converge or diverge the light rays falling on it. Each and every lens, either concave lens or convex lens, has its own power of lens. So power of lens is defined as the capacity, ability to converge or diverge the light rays falling on it. It is numerically equal to the reciprocal of the focal length of a lens. So P is equal to 1 upon focal length of a lens, where P, what is P? P is power of lens, F is focal length of a lens, and its SI unit according to the definition and the formula is per meter, which is also called diopter. And the power of a lens is measured by an instrument which is called diopter meter. When power of a lens is measured, an instrument is used. That instrument is known as diopter meter. Okay, so how can we define power of lens? Power of lens can be defined as the degree of to what extent the light rays falling on a lens is converged or diverged is measured in terms of power of lens. So we can define the power of lens in this form also. The degree of power of convergence or divergence of a lens is called power of lens. Power of a lens. It can be also defined by using the formula the reciprocal of focal length of a lens is called the power of lens. Power of lens. Okay, hence P is equal to 1 upon F. 1 upon F. So how can you define, as we know here? So just we can see with the help of diagram for convex lens. First try to draw convex lens. This is convex lens. And all parallel rays, light rays parallel to the principal axis. After refraction, they converge at focus. They converge at focus, and this is the power of convergence. So this is F1, F2, to F2, to F1. So this is the focal length and it is positive. So power of convex lens is positive because it has, so it is also called converging lens, convergent or converging lens. So the power of convex lens is positive, and it is, now again we can write here, but already plus is given, already it is in positive form. So power of convex lens is positive. So if the power of lens is given as positive, it means it is a convex lens. For concave lens, next let us consider concave lens. Let us consider a concave lens here. This is optical center, and this is F2, this is 2F2, this is F1, this is 2F1. Now all parallel rays of light after refraction, they diverge. So they diverge. Now this here again. So it appears to move backside. It appears to move backside. So power of lens, focal length is negative. So power of concave lens is negative. It has ability to diverge the light rays parallel to the principal axis after refraction. There are so many rays of light parallel to, so we can also draw like here in this form again. So this is now. So after that, so this is the power of lens of concave lens, okay, concave lens which is negative. So it is also called concave lens. Concave lens is also called divergent lens. Okay, so how can we define one diopter? It's very important question. So how can you define one diopter? As we know that the SI unit of power of a lens is per meter or diopter. Diopter, you can write here capital D. So P is 1 by F. How can? So if focal length F is taken as meter, then power of lens is diopter. So hence P diopter in bracket you can write, and F focal length in meter. Hence 1 diopter 1D is equal to focal length 1 meter. So 1 diopter is defined as the power of a lens. 1 diopter is defined as power of length, a lens of focal length 1 meter, unit meter. So 1 diopter 1, hence 1 diopter is defined as the power of a lens of focal length of unit 1 meter of the lens. So 1 diopter means the focal length of that lens must be equal to 1 meter. If the focal length is given in centimeter, while solving the numericals, it should be converted into meter. Then we will write its unit in diopter. Supposing one example, if focal length of a lens is 25 centimeter, then what will be the power of lens? Supposing we have to find lens is given as positive, so convex lens, it is convex lens, and F is given plus 25 here centimeter, so convert it into meter. Now 25 by 100, take 1, that is in meter, 1 by 4 meter. Hence P is, as we know that 1 by F, so 1 by 4 meter, that is 4 per meter, which is 4 diopter. So power of that lens, convex lens, is 4D. Okay, thank you, thanks a lot.